All right, so now we're going to take the region bounded by y, which equals x squared, x, the same region. And we're going to revolve it around x, which equals 5. Now, the general rule for this is that if you are revolving around a line that is to the right of your area, it is going to be subtraction. If you're revolving around a line that is to the left, it is going to be addition. You're going to add length to the radius in those cases, okay? Now, like on the previous problem, we had it below. Now, when your line of rotation is below it, that's going to be an addition. Now, if your line is above it, it's going to be subtraction. Okay, so I'm going to repeat that again. If your line of rotation is to the right, it is subtraction. If it is to the left, it is addition. If it is below, it is addition. If it is above, it is subtraction. Okay? And we're using this to describe the radius. There's a couple different ways to think about it, but the way I think about it is that I'm going to take that point and I'm actually going to subtract x for it, okay? And in this case, the way I imagine it, and the way you should think about it, is instead of talking about an expansion, why don't you consider this to be a contraction, okay? Not like a pregnancy contraction. So the volume associated with this one, now we're integrating in the direction of x. And so this is going to go from 0 to 2, okay? And we're still going to have our 2 pi, okay? All right, now when I said subtraction, what I meant by that was I'm going to call this 5 minus x, and then my height is going to correspond to x squared, and this is going to be an integration with respect to x. Okay, so what did I mean by these things contracting inwards is that if I plug the boundaries into that, what happens when I plug in x which equals 0, okay? So I'm at the point, yeah. Tell me if the microphone goes out. I charged it for a good amount of time, but okay, so when you're imagining this, if I'm at a radius, all right, so at this boundary point right here, 0, okay? If I plug 0 into this, well, first of all, the radius is going to tell me that this is 5 minus 0, which is 5, okay? And then it's 0 squared, okay? That's going to be the height at that point. And so then what happens is I contract inwards. When I get to this boundary point right here, what do I end up with? I end up with 5 minus 2. Now 5 minus 2 is 3, giving us a radius of 3 as we contract inwards. Okay, so this is, we're starting off with a radius of 5, but the height, according to these boundary terms, is still corresponding to this function, x squared, okay? And so as I go inwards, the height of my cylinders is still corresponding between 0 and 2. And so my height, when I get to this point right here, is going to be 2 squared. That's going to be the height of my cylinder as I get to the inner portion of it. But what is my radius of that cylinder going to be at that point? The radius of that cylinder is going to be 5 minus 2, which is 3. So whenever I do these problems, I try to actually, we want to visualize what is going on at the two boundary points, and does it make sense with the volume that you're actually trying to create, okay? So that's what the way you want to think about this. If this is your radius right here, you're starting at a radius of 5 and you're contracting to a radius of 3, where the height of all the cylinders is still going from 0 to 4, okay? So really try to consider what your boundaries are telling you in terms of both your radius and your height. And you can think of this as contraction, all right? So put this back in so I don't lose touch with it. Okay, so let's just go ahead and do this one. So Well, let's do some simplification work. This will be the integral from 0 to 2. All right, so that would be 10 pi times x squared and minus 2 pi times x cubed. And this is still an integral with respect to x. Okay. So that would equal now 10 pi and then x cubed divided by 3 minus 2 pi, now x to the 4th divided by 4. All of this evaluated at 0 and at 2. Okay. All right. So that would equal 10 pi now times 2 cubed divided by 3, then minus 2 pi. And now this would be 2 to the 4th divided by 4. Okay, now 2 to the 4th divided by 4, that's 16 divided by 4, which is 4. And that's, well, this is going to come out. This is probably just a nice little answer. We can leave it at this. Okay. So that's actually the answer to that problem.